Hi everybody, so I'm here to talk about how we built really quick some business dashboard for a product we have. I'm going to present how we did using Bonobo, which is a tool I created a few years ago, and using Airflow to put it in production, and Grafana to visualize everything. So first, I'm Romain Dorgueil. I founded a company called Makersquad a few months ago, and our goal is to build products and infrastructure for clients in a really quick way, which means that usually we put things in production in the first week. That doesn't mean finished things, but we are here to iterate with the markets to understand things and to adapt our roadmap during this. And we're usually building full products in a few weeks, like 6 weeks usually. Depends, of course. So today I'll present a product that we built internally. So you know the playground that was used for all these dashboards. Once this is done, I will present a bit of methodology and techniques we use to choose which metrics to look at and which metric we want to visualize. And then we'll go into core Python using Bonobo first to implement data pipelines to load data in a metrics database, visualizing this data using Grafana, and then monitoring things and going serious in production using Airflow. Of course, I'm a bit biased about Bonobo, so if you build something, make your own research, look at all available options. I think it may be a good one, but yes, we're all grown up here. Yeah, so let's first take some water and I will start presenting the product. So the product is very simple. It's an API that makes screenshots of websites. So basically, you say, I need 800 by 600. The URL is pyparis.org, and if we already have the image, we save it right away. If we don't have it, we launch a browser somewhere, make a capture, and save it whenever it's ready. It's not a new service. It's something I bought from someone that launched it a while ago. It was completely different technology. What did I do? Okay, it was completely different technology. So if we jump in time 9 years after, we relaunched it using only Python, or mostly Python, because Grafana is not Python, but yeah, mostly Python. The service is completely different. And one thing to note is that I'm lying when I say in April we served that, because the first thing we served was 500 and something, because we didn't expect the traffic that the existing service had. So it was a bit of panic at the time, but quite quickly we had it running. And I don't have the, okay. And so under the hood, it's like kind of microservice architecture, even if it's a bit of a buzzword. And the HTTP part, maybe I use the laser pointer, the HTTP part is quite standard. We have a Django website that just serves the user-facing website. So say, hey, we are making screen capture. You can register, you can see your API keys, you can see your statistics and stuff like that. And we have a really small service, which is the real service called, we call it API server. It's written with Tornado, and the only role it has is if an image, if Redis says an image exists, then it will either save it from local cache or from the object storage after downloading. And if Redis says it doesn't exist, it will send a message to a message queue that says, hey, crawl this thing. But there is a little cop in the middle that says, should I really crawl this thing? Because if you let the user crawl any, like use your cluster for anything, you may have problems. So the janitor will decide whether or not this request is legit. If it is, it will send a crawl message to some command queue, and a spider will pick it up, open a browser, make a screen capture, upload it to the object storage, and send a created event to the message queue so the janitor can update Redis, and next time a user comes to the API server asking for the same image, the image will be available. So that's the whole service. Behind that, we have a lot of other services that produce a lot of data, mostly technical data, but also somehow business-related data, like all the external services produce data that are very interesting to analyze after. Mostly in the internal services, we have one central thing that produces data, which is Prometheus. It does not really produce data, but it's a timestamp-oriented database. So basically, it crawls everything within the cluster, gather metrics, stores them, and allows us to query that. So we won't build the Grafana part from scratch because we already have a before the beginning of this presentation, we already have a Grafana instance running. It's pretty easy to run nowadays with containers and stuff like this, but we only have, at the beginning, technical metrics in this Grafana instance. So we gather CPU, memory, like some message queue related metrics, and things like that are really useful when we need to inspect some incident we have. Like the service explodes, we need to quickly see what did explode and put it back up. But we store those metrics in a really fine-grained way. We may have one data point every second or even more. But we only keep that for 15 days because if after 15 days we did not have to use this data, probably it's not useful anymore. So for the business dashboards we're going to build, we will probably gather some of those metrics, but aggregate them in some longer periods of time. So we can use that, but for now we only have the instance and some technical metrics here. So what's the plan? Basically, it's summarized here. If you don't measure something, it won't improve. And if you want to improve something, focus on it, measure it, so you can actually have the right focus and know what you're talking about. We wouldn't be able to improve our response time if at some point we were not measuring it and focusing on it. So it's just one example. But yeah, usually if you want to improve something, you need to measure it first. And there's a lot of things, but we need to be careful in choosing the metrics because we don't want to focus on some metrics that are just a consequence of something else. We want to focus on the causes. For example, I don't know if I said before, but we get around 1 million image requests per day. That's a totally useless metric. It's good to brag in conference and say, yeah, there is 1 million requests per day. I don't know if it's a lot or a small number. I don't really care, but that won't help that's useless for the business. I mean, if I increase this number, I just increase the costs of the business and nothing more. So that's something we want to avoid. Yeah, that was the next slide, but yeah, something you really want to avoid. We call that vanity metrics, and yeah, we don't want to waste time on that. To plan what metric we want to measure, we will build on the work of other people, like in code, in like measuring things, a lot of people worked. And maybe a lot of you know already about that, but who knows about the Pirate metrics? Nobody? Okay. So the Pirate metrics is, I don't remember who pinpointed this term first, but it's a simple way to segment metrics about your user journey in 5 simple steps that you can find pretty much in every kind of business. I mean, the upper side is a SaaS business, but even if you have like a mobile application, a mobile game, something like this, you can have the same funnel. And this funnel is segmenting in the acquisition phase where you discover new users or the new users discover your service. The phase of activation where the new users are interested enough with your service to give you a bit of something about them. For example, they sign up or they download your application or things like this. Then it's not enough because the internet is wide, so you need to keep them coming again and again. So there is this retention phase where you try to get them from identified user to some active user and recurring user. You have this revenue phase, which I switched both, but the revenue phase is when you start getting value from the user. I say value and not money because some services are paid, but some services are just getting value from, for example, the data that the user will generate. If you take Medium, for example, people writing articles are giving value to Medium, even if they also have a subscription service now. And there is this referral phase where the user loves your service so much that is willing to sacrifice a bit of his social existence to share it. And in fact, is using your service to say, hey, look, I'm using blah, it's so cool, you should try it out. And in fact, he's not speaking about your service, he's telling his friend, yeah, I'm cool because I'm using this service, so yeah, it's something I put at the very end for this reason. And you have much more complicated schema for the same thing, but this one is specialized in SaaS work, in software as a service businesses. But if you look at it closely, you will find all the phases you have before. So this kind of workflows of journeys is more useful when you grow, when you're getting really big with big teams, so everybody can focus on very small details. But for now, we just can stick to the plan A, to the R framework, to the Pirate metrics. And mostly we will focus on the activation phase for now, because yeah, we're early product on this thing. So today I'll focus on measuring two things. I said we should focus on one, but I will do two. I will focus on the rate from acquisition to activation. How do we measure that, store that, and visualize that? And on some metrics linked to the quality of service, because to convince users they should sign up, we're competing with other equivalent service, and the only metric that we can, the only thing we can show to say yes, we're better, is to tell them we have a very good uptime, we have a very good, very small response time, and yeah, we need to prove we are better. So that's the two kind of metrics we'll. Well, this one is one metric, and this one is a kind of metric we'll focus on today. So, oops. So the plan is to use Bonobo to, and I'll explain a bit what it is after. Who heard about Bonobo before today? Okay, a few numbers. Okay. The idea is very simple, is that we will read data from a lot of different data sources that I showed before in the architecture schema. We'll aggregate them all in the same format, like it's basically dimensions to metrics, and it's time dimensions to metrics, and we'll put that in a very simple database that I will really quickly design on the next slide, which will be simply a table of metrics and two tables for hourly and daily values. Of course, if you're a big business, you will create a much more complicated thing that may even be like on-the-shelf products that already does that. But that was quick to write, not the best, but enough for what we want to do. And if you want to read more about that, there is all the business intelligence things on the internet, and you can look for star and snowflake schemas if you want to design your own dimension databases. So, yeah. And so Bonobo is an extract transform load framework. It's basically an assembly line for data lines. It's taking regular Python data structures and streaming data through a graph of those data structures. So for example, here I'm using both things that are, let's say, callable or iterable, and regular Python functions. Here it's linear, but we'll see a graph, a real graph after that. And the idea is that if, for example, the select need to select 1 million rows and starts yielding data as soon as it got 100, it will continue its work, and qualify will start running in parallel on each row one at a time. So it's really streaming data through Python callables and iterators. Data is passed first in, first out. It's row-based. So if you have big aggregation to do, it's probably not a good idea. Like if you want to aggregate the whole data set, it's not a good idea. And yeah, it's just use standard Python, and you can probably install and run your first transformation before I finish this sentence, if you're real quick. But maybe I just pass the next slide. So let's write some jobs. The first job we are going to, so I'll take a bit of time on the first job, and then we'll run quite quick, so we have time for the two other tools. But the first job will be to extract to simply count objects from the database. So on the website database, we have different tables that are of interest for us. So I won't get into the details of that, but we just select, oops, that was not expected. Okay. We just select from different tables, and in fact, the tables will be passed as the input. So the goal is to count everything and return a tuple of the dimensions, date and hour, and the metrics. So we name the metrics after the table name, and we put the count here. So this one is very simple, as it will only get 3 lines of data. But we use a standard dict.items iterators to pass the data into this object count reader. So each of those lines will be passed as, well, each of those tuple, table name, metric name will be passed as this object count reader. We'll see the construction of the graph after. After this, let's say, extract chain, we'll normalize things. So here, I don't want to write some complex schema validation, so I just use something that says that there should be 2 fields, and they will be named dims and metrics. The good thing about that is that it works at first. If tomorrow I want to use something like Marshmallow or some other schema validation tool, I can very easily substitute this simple thing by something else, and the whole rest of the graph will stay the same. Then I need to write into the database. So here again, not going into the details, but I'm getting rows as the input. I will make sure I get the metrics from the database, or create it if it doesn't exist yet. And for each metric value, I will insert it in database. And self.put is from the inserter updates parent, so that's provided. It's in the Bonobo SQL Alchemy extension. And so I'm just using the parent logic here to insert the thing. Now, the composition is the most interesting part, is that we are actually building the graph data structure here. We built our normalize function before. So we put the readers here, we put the normalize here. So the beginning of the chain is this thing. And then we add twice 2 instances of analytics writer, both for hourly value and daily value tables. And we have a simple lambda that will filter at the beginning. I didn't say it, but there is just a simple thing that says, if it's not for me, let's skip that. And so, yeah, both tables will be using the same node to insert the data. Graphically, if I inspect the graph, it's exactly what I showed before. We have these dict items yielding rows to the object count reader, yielding rows to the set fields, yielding rows both to daily analytics writer and hourly analytics writer. Yeah, so that's the first transformation. Yeah, one important thing I forgot is that I never defined the connections before, so probably it's something you prefer to define at runtime because it differs from your laptop, your production server, or some staging servers. So now I need to provide, I had names before, like SQL Alchemy engine and website engine was defined in the transformations. During the bonobo.run call, I will provide the actual implementation to use. Yeah, so here it's just SQL Alchemy engines, 2 different. And I can run it just using Python. Here it's a module, but you can just run it like this. OK, this one is not very interesting. There's only 3 lines, but let's add some more readers. So we wrote a Google Analytics reader. Very simple also, because Google Analytics is already a dimension metrics database. So it's just an affair of choosing which dimensions are of interest to you. And we just format the data the same way with a tuple of 2 elements, one of the dimensions and one of the metrics. There is the Prometheus reader that's just query the TSDB. So it's an HTTP service. We will provide the HTTP implementation later. Here it will be requests, but you could switch that for example, some cache, some request implementation with some cache. And yeah, pretty much the same after that. We just query that, format that the same way as before, and we have dimension matrix tuple here. Another one a bit more interesting, we have some spider status table. So every spider reports its status, And here we want to get the number of spiders at a given moment in time, but this table is not, how to say, I mean, each spider has one line, so we don't want to get one line per spider. We want to aggregate that, so we just select all the, let's say, valid status, and then we'll use a reducer, which is quite similar to Python functools.reduce. Well, the parameter to functool.reduce, it takes a left and a right value, and we are just aggregating the counts of the total number and active and idle spiders. And then it works basically like functools.reduce, but it's for streaming. So here we have spiders reader that will yield rows to reduce spider reducer with some initial value. And at the end, we have a lambda that will take the output of reduce and format it the exact way we want it. And yeah, there's probably more. I don't remember, but there's probably more like this. And now if we inspect, we have a real graph. The dot here is the, let's say, the beginning of the graph. So everything connected to this dot will be called at least once, will be called exactly once, in fact. And then we have all this chain of data that are streaming data to the set fields, which will send data to be written in the database. If we run it, there is much more now. So we have the, yeah, it's, of course, the console is kind of linear. It's line by line, but you can see that, for example, this line sends here. We can see using the numbers, but we can see also that those lines are not linear at all, and that the last one is taking everything from before and pass it to the writers. So, yeah. And of course, you would see that the numbers change while it's running, but that's just in the middle or at the end because it's finished. So once again, I'm biased about that, of course, but I really like just to be able to replace parts, to write small parts. It's really, we write software really too quick to be good, so we need to be able to write bad thing at first, and whenever it's exploding, we replace some parts. So it's really modular. It's nice for that. Okay. So, who never heard about Grafana? Okay, quite a few. Grafana is a simple, so you've seen it before, but the goal is to connect to some data sources and make graphs. And those graphs, you can build them directly in the browser. You have a query editor, and you can just build them in the browser and save them and share them with your team. So it's a really nice tool for visualization. It's really fast. So once you set it up, it's really fast to build graph. And for example, the query editor for SQL is looking like this. So you have the preview at the top. You have the query you're building here. There is some parametric thing here. We have a time filter that will match the time parameters user will use. And if we see the real version, you will get this graph. So here it's the graph of the events going into the message queue. I don't know if it's from the janitor or probably from the janitor. And yeah, so we count every kind of events we get. There is failed things, there is successful creations, there is some just crawl requests, and we count everything. We counted also the spider reducer thing I showed before. We can visualize how many spiders are running at a given point of in time, how many are active. So here, when I took this screenshot, there was a lot of inactive spiders. A bit of a waste, but better than the opposite. And most importantly, we started to count how many times, on average, we did need to create a screen capture, knowing that the user can request barely anything, any URL. So, of course, they give us very bad sites. They give us some very lagging sites, anything you can imagine. Some people try to abuse some affiliation and things like this. So at the beginning it was, how many it was? Like, we didn't improve much because now we are on average at 14 seconds, but what we improved a lot since the screenshots is sometimes there was spiders just hanging on some on some URLs and spiking the delta between the requests and the image created to a lot. So blue is on the left, so it's 15 seconds, but right, sometimes we had a spider hanging for 13 minutes, which is obviously not good. And we don't have that anymore. And we use that also to present public statistics. So that's not Grafana anymore, but we use C3 to just build from the same data, the exact same graph, but a bit more user-facing. So we tried to make it a bit nicer. Yeah, it's not really live because we cache it for half an hour, but yeah, it's lagging half an hour just. Now the acquisition rates. Well, we aggregated the data from Google Analytics, and we aggregated the data from like not aggregated, but we counted every hour how many users there was in the database. So it's pretty easy in SQL to just make a ratio between two. So we used both SQL queries, we compiled them in one, and we just had the amount of new users per hour or day, per day, and just percentage. So that was the very beginning, the launch. So at the launch, we had very high conversion ratio because we were re-onboarding all the user base. So I think 25 conversion ratio is impossible in, oh, I don't know what is your product, but I'm interested if you have this kind of conversion ratio. But yeah, now it's way lower, but yeah. So data needs to be contextualized to be understandable. And yeah, we built some more since then, and now it's basically 10 minutes and we create a new graph as long as we have the data, and even writing a new extractor is very, very, very quick. So on my laptop, it runs pretty well when I run it manually, but of course I don't want to watch it. I want to run it automatically in some clusters, some machines, not very important where is it. And the first thing we did was a cron job. A cron job is like a cron tab, but for a Kubernetes cluster. It's just something that spawns a container every X minutes and just execute a thing. Problem with that is it's hard to know if something fails, because yes, we have the logs, but we have to look at the logs. We have to look at ask for the logs to the cluster. So not easy to know if something fails. Not easy also to say, okay, some task I want to, or we could have made a lot of different cron jobs, but we did only one that runs everything. So it was hard to say we only want the expensive maintenance tasks daily and a lot of tasks running every 30 minutes. And when we were developing the thing, it was also hard to run manually, to test things. We know something is wrong, we want to try it, we had to schedule something in Kubernetes. It was a bit not really easy. So we went for Airflow, which is, according to the documentation, a platform to programmatically author, schedule, and monitor workflows. And by workflows, that means anything that can run on a computer. Another definition that I like is that it's like a cron tab and a makefile for clusters or for real infrastructure. It's both. So the cron tab part will allow to schedule things, and the makefile part, it's not really exact, but the makefile part will allow to define dependencies between tasks. So you make sure that the prerequisites are finished before you start the next thing. We choose it mostly because the project joined the Apache incubation program. There is some other tools that are similar, like Luigi, that was made by Spotify. Spotify. But as this one joined the Apache incubation, even Spotify said it started to use Airflow for some things. We went for this thing. It can use a wide range of strategies to distribute work. We are using Celery because the Kubernetes one was not stable and ready at the time we started. Maybe it is now, I don't know. You can basically run anything that can run on a computer. You can run Spark tasks, you can run, I don't know, shell scripts, whatever you can imagine. that's an overview of the architecture, but basically you have a web server, like a web interface that you can use to interact with it, know the status, and send orders, read the logs, things like this. I will show after. It will write things to the metadata database. There is a scheduler that reads from this metadata database and decide what to schedule on the workers. And how does the worker look depends completely on the executor you choose. So that's not really exact on every situation, but basically it's that. And as we use the celery executor, that's celery workers. Il me reste 5 minutes. Okay. The interface is looking like this. You can disable thing, activate thing, read the logs when something failed, run something again, etc., etc. So I'm short on time, so I will speed up a bit. The definition is in Python. It allows to define graphs also, like Bonobo, but the graph here is used to define the dependencies and not the stream of data. So that's the big difference between two. This one defines when A is finished, do B, then when B is finished, do C. In Bonobo, you say A, B, C, and whenever something goes out of A, it runs in parallel in B. We also use some tricks to define the connections directly in Airflow, because there is a connection concept. So hey, come back. We use basically environment variables to pass this to Bonobo. One thing we learned is that the Helm charts, like Kubernetes charts for Airflow, the community ones are not really good, but there is a company called Astronomer that makes, amongst other things, Airflow has hosting as a service, and they made really good distributions of that. So if you go for Airflow and Kubernetes, you should look at their work. It's really, really good. And the source of Airflow is also really good, so it's really easy to read through. So I highly suggest you do that if you miss some documentation. So I'll say it again, but yeah, Bonobo is streaming data, while Airflow can help you manage the whole factory. If you have, I've seen people, I don't have a lot, but I've seen people having hundreds and hundreds of tasks in Airflow, and it's really a very good overview of your data management thing in your enterprise. If you have any comment, anything to say, I don't know if you have a bit of time for questions, but you can reach out to my email or even on Twitter. Feel free. I will be here all day also, so feel free to grab me some place here. And yeah, if we have a few minutes, 3 minutes for questions. So thank you very much. And